So good morning, everyone, or good afternoon, or good evening, or good noon, everyone. Thank you very much for participating in our webinar of the MaDiTraCe project. I will give you short technical instructions, so please be sure that your mic is muted, but I see that it's automatically that case. We will have a Q&A session at the end of the presentation. You are free to share your questions within the chat. I will take care that they are addressed in the Q&A session at the end of the webinar. So just the agenda for the follow-up webinar. So we are starting with a short introduction by Daniel, the manager and coordinator of the project. Then we are giving a very short overview about the CERA Form 1 system and what it covers and what it is about in general. Then we are having a deep dive into our CERA final product standard by Samuel. And then we are getting over to the chain of custody standard, which is the most interesting standard currently in the standard landscape, all about transparency, traceability aspects. And then a little bit taking the view on the challenges and that we have with other technologies in the project, which will Daniel tell you about, which is digital traceability and analytical fingerprinting. So how we integrate that in our certification scheme, how we manage to handle that, and what challenge we had doing the development. And we're ending up the webinar with the Q&A. And now Daniel, you are taking the floor to present MaDiTraCe.
Yeah, very shortly. So thank you very much. Thank you for coming to this webinar of MaDiTraCe Project. So MaDiTraCe Project, we are a project funded by the European Commission. We are a research project Horizon Europe, so it's a research project. And we had the ambition when we started in 2023, to bring more transparency and work on traceability of supply chains of critical raw materials, mostly aligned with battery raw materials. So because there is a big regulation that it's coming, which is EU battery regulation, and we had also in mind to incorporate also obligations and things coming from corporate sustainability due diligence directive. This directive is now being discussed, etc. So I'm not going to go into this debate. But in any case, the objective of this MaDiTraCe project was about raw material traceability, and I will speak very quickly about what's our interpretation of traceability in next slides. So maybe next slide, please. So in the project we have mostly 5 objectives. First one was identify which are the gaps in current due diligence practices and assess manufacturing and OEMs industry needs in this field. It's a very complicated and very complex because there are many documents, many initiatives on parallel, and it's quite difficult to navigate. And that's in the project, that was mostly the work by Montan University in Leuven in Austria. And I think that my colleague Paulina is there today. We had a second objective that was to work about material fingerprints, so all the possibilities and potentialities that intrinsic material characteristics of different commodities that we are working on it. We can trace those materials along supply chains, and we can detect those intrinsic fingerprints. And that makes that with this fingerprint, we can trace the origin, and we can try to validate and verify the origin of your material. Third one was integrate these portfolio solutions in certification schemes. That's the objective of today's webinar by colleagues from DMT, one of the partners of the project. Fourth objective was to connect all those things with, in traceability and raw materials traceability. In this moment, there are plenty of technical solutions, blockchain traceability, digital product passport, etc. So it's integrate all those things into these technological solution providers. So and the end is for sure we have an objective to communicate and implement our results, have a dialogue with the stakeholders, and The example is today's webinar. So we have also this objective to share our results or our challenges as well with a community of stakeholders, mostly in Europe. Next one, please. Yeah. So the impacts more or less are related also to the objectives of the project. So it's improve supply chain traceability and transparency in supply chain data. This address gaps in due diligence. I think that was it's a very important task to understand why and where we need more traceability. Yeah, deal also on the have a dialogue between geologists and raw materials experts, material experts, engineers with IT community about digital traceability. That's also this dialogue is important in the project. The develop CERA 4-in-1. Once again, it will be presented after me, and also, yeah, bring a family of tools, a set of tools to provide solutions for trace the origin of raw materials in a world which is becoming complex, and you know what is happening about raw materials in this moment. So I think that's also important to have in mind. And also we have a battery of regulations happening on the field of critical raw materials, where traceability is also a part of this regulation. Next one. So just two more slides from my side. Why traceability is important? Traceability is important, and here we have two examples of last 2 years. A situation in Myanmar in the okay, so it's just my computer going to. Can you hear me? Okay, because I had a problem with my computer. Sorry. The cross-border area in Myanmar, China-Myanmar, we have certain illegal mining practices in this area with a army conflict as well. So it's certain practices of the risk of pollution to water, etc. So here there is typically a case where we need to trace and we need to understand if we are sourcing from those conflict areas. That's the example in Myanmar, and we had the example also in DRC, in Congo. That's last year. Now the situation seems that is becoming peaceful. But in any case, there was a question about do we have metals coming from conflict areas? Traceability is not only about conflict areas. We can also have a positive way to trace. Is do we want to trace materials coming from well-known sources, where from mines or for suppliers or for refiners, etc., that are doing things according to certain certification standard. And that's why standards are important. And maybe last slide, please. So I like to present traceability as a sort of triangle, where we have in one corner we have digital traceability, digital product passport. That's one part of this technological solutions to that, and that we have many different companies providing services around that. We have in our project a partner, Spherity from Germany. They are providing services on that. Later we have certification. So certification is important because we want to transmit information about the materials in a product, the materials in a matrix that comes from a certified source, and that's the objective of the webinar of today. And last but not least, this material fingerprint. So that means working with material and tagging and intrinsic characteristics of materials, how we can verify and check if any declared origin of materials it's coming from certain sources. So that's all from my side. So I don't know if I'm presented correctly. So I'm the project coordinator of MaDiTraCe Project. So we are 13 partners from different entities, universities in Europe. So please stay tuned to to our social media website, etc. We are ending the project, so the project will be ended in June. And yeah, we have many information in our website and also in other channels. And yeah, happy that we as French Geological Survey to coordinate this very exciting project. And now the floor is yours, Lucas and DMT colleagues.
Thank you, Daniel. Yeah, by having the view on the traceability challenges globally, and again, there was a few days ago an additional mine collapse in DRC. So it's a hot topic still, and it will be, and that's why the focus will be especially on the two standards that we want to present in detail today. So just in general about the current situation and CERA Form 1, how to fit CERA Form 1 in the global global, let's say, discussions. So CERA Form 1 overall wants to prove sustainable development along the entire value chain. So we have standards for every part of the value chain. Of course, which is a topic out of discussion, is that we are focusing on all kind of minerals globally, from industrial companies of any size, so small to large scale industrial size. By implementing this standard, we're trying to support the company in being legal compliance, especially when the upcoming regulations are coming with battery passport, CSDDD, the German Supply Chain Act, the CMR Act, and so on and so on. By giving the company or supporting the company in producing and generating verified, trustworthy data. The transparency issue will be further discussed during the webinar. So we have interfaces to digital and analytical traceability. And overall, we are trying to streamline the ESG assessment of raw materials, mineral raw materials sector globally. So coming to the standards, CERA Form 1, why CERA Form 1? Because the initial idea was to have 4 standards in one system to cover the complete value chain. One standard, we split it a little bit, which is the performance standard. So we have the readiness standard for the exploration part. We have the performance standard upstream for the mining, processing, smelter part. We have the performance standard downstream for the manufacturing. The chain of custody standard covers all output materials at every stage of the mineral raw material value chain, and the final product standard is the claiming standard, what to claim in which way, and so on and so on. So it just gives you a guideline on how to claim about your product, which is then related to any ESG aspect. Rather, it's on the operational stage, or it's more on the claiming of the product of the output material. Here in detail, so the exploration and mine development defines the criteria for responsible conduct of mineral exploration projects and mine development projects. The CPS is the typical on-site standard that can be implemented on mining, processing, smelting, refining, manufacturing sites. It defines also ESG criteria on the operational side. The chain of custody standard is the supply chain standard, and it defines criteria for the traceability of responsible source, primary and secondary materials and traded commodities. And the final product, again, provides guidance on how to communicate, label, and make claims across the CERA Form 1 certification system, which becomes crucial to avoid greenwashing. Overview, a little bit to define the objective scope of CERA. So it's sustainable development. So it helps to attain sustainable development across the supply chain. We try to target all kinds of minerals elsewhere in the world from any kind of industrial size. I already told you that. We facilitate legal compliance. We provide transparency in the supply chain, and we want to harmonize this system. So up to you, Samuel.
Can you go back, please? Okay, Lucas, thank you for that overview. Now I will focus on the final product standard and more specifically on why claims governance has become such a critical topic and how CFS addresses this challenge. Next, please. So the final product standard sits at the intersection between verified performance and external claims. So to understand why this interface has become so important, we first need to look at the pressure companies are currently facing when communicating sustainability. As we can see, so sustainability claims are now widely used across corporate communication. So they appear in customer-facing materials, online communication, sustainability reporting, and different interactions with different stakeholders like buyers, partners, and so on. And at the same time, expectations has increased. Buyers, consumers, and regulators expect claims to be clear, accurate, and verifiable. But the reality is that practice hasn't always, let's say, matched those expectations. And according to the EU, a large 50% share of environmental claims are considered unclear or potentially misleading, and many of them lack sufficient evidence, and verification is often, let's say, weak or inconsistent. So for example, in the mineral value chain, we often see claims such as, let's say, responsibly sourced material or ethically produced mineral. And in many cases, these statements are not completely false, but they are not they are so broad that it's unclear what they actually refer to, which part of the supply chain is covered, or what evidence sits behind them. So this is the kind of ambiguity where greenwashing risk starts, and the consequences or resulting risks are very clear and real. So companies risk losing trust, undermining their credibility, and also exposing themselves to reputational and legal risks. Next, Lucas, please. And that's why regulators have started to act. So we had seen a very clear reaction from regulators to the problem of unclear or misleading sustainability claims or greenwashing in general. At the EU level, so we have the Green Claims Directive and the Empowering Consumer Directive that set explicit expectations for how sustainability claims can be communicated. So this means that, for example, vague, generic, or potentially misleading claims are no longer acceptable. At the same time, something that was already mentioned, so the eco-design for sustainable product regulation brings in the digital product passport, and the idea is to increase transparency and facilitate access to a more structured data. When we look at all this together, so the main idea is that sustainability claims needs to be supported by data and credible evidence. Another aspect or situation regulators are focusing on is when facility level certification are presented as if they automatically apply to all materials or products, or even we have discussed during the development of the project, or even to components of a product without clarification or disclaimer. So the lack of precision is something that the current regulatory frameworks are also trying to address. And essentially, this is not about limiting the claims, so company can still be claiming their sustainability achievement. It's about reinforcing internal governance around how claims are created, validated, and finally approved. Next, please. So we have that regulations, they refine what is expected. They define what is expected. Digital tools support access to data. What is often missing is a clear governance framework that defines what can be claimed, how claims must be worded, and under which conditions claims can be made. So this is where the final product standard comes in. Next, Lucas, please. Yeah, thank you. So as we already mentioned, CFS is part of the broader CERA 4-in-1 certification system. Its purpose is to define the rules and guidance for how verified information from the system may be communicated externally. It applies across different claim types and communication contexts, covers B2B and B2C situations. This means that CFS governs how verified sustainability information is translated into external claims. Next. So here we can see how CFS fits into the system. So we have that responsible practices, ESG performance and traceability are addressed upstream or across or along the whole value chain via CRS, CPS, and CCS. The certification and assurance ensure that all this information is verified, auditable, and supported by evidence. So based on this, let's say, foundation, CFS governs how that verified information is communicated externally. So in practice, CFS acts as the interface between verified performance and external communication. And I would say that this, let's say, separation is essential for credibility, market credibility. Next, and the last one. So to conclude, we can see that companies are facing scrutiny not only on what they do, but also on what they actually say. And in this sense, our standard helps manage this risk by ensuring that sustainability claims are evidence-based and aligned with verified data. From a business point of view, this reduces a company's exposure to legal and reputational risk, strengthen also credibility, and builds confidence among like the different stakeholders. There is also an important downstream effect that I would like to mention, and is that when sustainability claims are clear, specific and backed by evidence, they allow buyers or consumers to make more informed choices, not because they are told what to buy, but because the information they rely on is trustworthy. So with that, yeah, I will hand over to my colleague Tania, who will now focus on the chain of custody standard.
Thank you, Samuel. So hello, everyone. Good morning, and my name is Tania Nawaz, and I will be talking about chain of custody and as well as integration and challenges of other technologies. So we are all aware, and we've been talking through in previous slides about the growing concerns around conflict minerals, minerals which are associated with severe environmental, social, and governance risks, as well as minerals which are originating from sanctioned countries. And somehow they always enter into the formal supply chain, and ultimately they make their way into the products that we are consuming. So who are in the hot seat are the downstream organizations. They are often in the limelight for the wrong reasons, saying that they are promoting conflict. Name brands like Tiffany is associated with blood diamonds. VW, that is Volkswagen, is also made of conflict minerals. Apple, Intel, Tesla, all of these companies were named in the ITSCI laundromat, a report by Global Witness, which showed how these conflict minerals make it into our products that we are consuming. So other challenges are also there in the supply chain. Apart from that, is that suppliers are not willing to share information. Perhaps they're not willing to share information about their product, conditions under which the product was made, or information about their suppliers, because they think that they're going to lose their customers. And another thing is that collecting information from them, or collecting, say, the suppliers collecting it from their suppliers. What information is exactly needed? There is no standardized template to do that. And we also know that there are different regulations which require different information. So if the organization procure from all of these sources, which is laden with all of this ESG risk, the larger organizations are always going to be blamed. And also, they are also under the constant scrutiny of the different stakeholder groups like consumers as well, who are now more aware. They demand to know the origin of the materials in their products and the conditions under which the product was made. One misrepresentation, one fraud charge can create consumer awareness that certain brands cannot be trusted. This can have a severe repercussion on the brands itself. So in response to all of these concerns, as you can see on the left-hand side, there is an increase in the number of regulations. These regulations, they are demanding that the companies determine where the materials are actually originating from. They are pressurizing the organizations to conduct supply chain due diligence and to ensure that the journey of the product, like right from the mine till the time that they are placed on the shelf in the markets, that it is traceable. So the organizations need to integrate traceability systems. And though traceability, they say, can help to hold companies accountable, there are a lot of different ways that the organizations can actually implement these kind of traceability solutions. But one approach that is particularly gaining attention is chain of custody. The concept is already well established in the food, the timber, and the textiles industry. So what exactly is chain of custody is that ISO defines chain of custody as the process by which inputs and outputs and the associated information is transferred, monitored, and controlled as they move through each step of the supply chain. So in other words, we can say that it is tracking the information of the material, the associated information about ESG, from one actor of the supply chain to the next. And why exactly we need to track is so we can trace it backwards. It provides a way in which the required information can be collected from all of these different actors of the supply chain and be compliant with regulations, and at the same time be, they can avoid the complicity to the different ESG risks. Next slide, please. So as I already mentioned that, yeah, they can comply with regulations. It can help to foster traceability. There are other advantages of having chain of custody. It can help to identify where exactly the risks lie in the supply chain, where there can be an issue that certified materials can be mixed with non-certified materials, where the hotspots are in case of emissions, or maybe some material that is originating from areas where there is severe human rights violations, for instance. They can be addressed, they can be identified as well as much faster. Another example is when a potential risk is identified, say a material from a high-risk region entered into the supply chain. Instead of stopping the production entirely or relying on assumptions, chain of custody will give the opportunity to the company to pinpoint exactly which one are the affected batches, isolate the issue, and continue operating with confidence. So it helps to increase transparency. They don't just get to know who their suppliers are, but how their products are handled, how they are faring in terms of all of these environmental, social, governance risks that is being associated with the operations. And through the different models like identity preserved, segregation, which we will talk about later, they can confidently communicate information about where the material was sourced from and that it is fully certified. By this, they can also satisfy the market demand. Next slide, please. So as already introduced by Lucas, the CERA 4-in-1 chain of custody certifies a facility or a sequence of operations and helps to determine the criteria for the traceability of responsibly sourced primary and secondary materials and traded commodities. So the chain of custody standard itself is actually divided into 4 topics. One is responsible sourcing, and you can see the others. So responsible sourcing, where it's ensured that whether it is, let it be primary material or secondary material sourcing decisions, they need to take into account environmental, social, and governance risk. So if a material is sourced from a certified facility, for instance, the organization does not have to do much. They can just record the certification number, the name of the supplier, and they can continue with the operations. But if the material is sourced from a non-certified supplier and say it's providing a conflict mineral, then they have to do extra checks. They have to conduct extra checks in line with the OECD due diligence guidance for responsibly sourced minerals from conflict-affected and high-risk areas. Or they have to consistently monitor their performance if all the checks that they have put in, is it working or not? So responsible sourcing alone is not enough. The organizations themselves have to have responsible operations. That means they need to have all the internal systems, the policies, the processes in place to meet the minimum ESG expectations, which is highlighted in the standard. And or also they can be certified by the CERA performance standard, the upstream or downstream, depending upon where they are in the supply chain. The third part is responsible handling. So now we are moving away from ESG and we are looking into how the material is actually being handled. There are different chain of custody models, as I have mentioned earlier, which is identity preserved, segregation, mass balance, and control blending. And they're all defined in the standards to prevent mixing, to prevent the loss of integrity of the materials, to prevent any kind of misrepresentation of the certified materials in products. So these chain of custody models, they have their own handling approach, level of traceability, costs. For instance, say IP that is identity preserved, it might require more costs because you have to keep even the materials from different origin separated. And depending upon the capability, the requirements of the market, regulations, the organizations can adopt either one of these models, COC models. So there is another model that is book and claim, which certainly does have its advantages, but it's not considered in the CERA 4-in-1 chain of custody standard because there is the lack of traceability of the materials. And if the organization has all the three elements, that is responsible sourcing, responsible operations, and responsible handling in place, then they're in a position to be able to make responsible claims, which is a result of the responsible practices throughout the supply chain and also in line with the type of chain of custody model that they have used. For one, for example, if they employed a no mixing model for identity preserved, then they can make a claim about the origin that their product is from this particular mine. Or if they implemented segregation, for instance, then they can make claims about that their product is fully certified. What is important to highlight here is that chain of custody standard is fundamentally built on documentation, on the controls that the organization needs to have and verification processes. But we are talking about volumes and volumes of data, about materials, about transactions related to those materials, about information about all of these supply chain actors of so many different tiers. So it becomes challenging to keep an overview of all of them, especially if you have to collect the information, you have to organize, analyze this information, and share it with the next actor in the supply chain. And this is exactly where technology becomes relevant, which brings us to the next slide. Please, Lucas. So this is the next and the last part of the presentation, integration and challenges of other technologies. So as I mentioned, that chain of custody will require the presence of technologies. And you can see different technologies, which is provided on the left-hand side of the slide. So there are barcodes and QR codes. Of course, they're widely adopted because of their simplicity and the low cost. We also know of the RFID tags, which enable the automatic real-time tracking of the materials, and it's also quite widely used. And you can do it through scanners and using databases, reducing the chance of any kind of human error. So material fingerprinting has also emerged as a potential solution to verify the geographic origin of a mineral. And last but not the least, we have also blockchains, a topic which is very commonly discussed in the academic sphere as well as in industries as well. They are used to secure the chain of custody data through smart contracts and decentralized storage. So these systems, the blockchain systems, they enable tamper-proof records of transaction, increasing the trust between the supply chain partners and auditors. They all help to potentially collect the information, the required information, and provide the proof of provenance, and also helps to link the material with the transactions. Next slide, please. So we have seen a lot of solutions do exist, but they do have their advantages and disadvantages, like the material fingerprinting technology cannot work without a fully populated database, for instance, or blockchain is only as good as the data that you put in. Barcodes, QR codes, yes, they're quite easy to use, but they can be easily manipulated as well. Cost for integrating a technology to put in the infrastructure that you need to operate the technology can be quite high. And human intervention is still needed to validate the information that is being put onto these systems. There is a lack of guidance, which is also present, which is and it leads to inconsistent interpretation of what the requirements are actually asking for, the standard requirements, for instance. And with these technical solutions, they would require also technical skills. And lack of technical skills is often cited as one of the most common challenges that is faced by a majority of the organizations. And most of all, they might have to invest in a technology which is helping with traceability, whereas they could have used the same resources to, say, improving an environmental or social aspect. So these things, these challenges must be taken into consideration. Next slide, please. So far, we have seen that technology clearly has potential, but it also comes with its limitations, as we have discussed about high costs, scalability challenges, skill gaps, and a continued reliance on the human intervention. Means that technology alone cannot be a silver bullet for traceability or for responsible sourcing. So this is exactly where the challenge lies, not in choosing whether the use of technology, but in how it is applied, how this technology is governed. The approach which is taken by the CERA 4-in-1 standards does not treat technology as a standalone solution. Instead, it integrates the digital tools within the standard that defines what data is exactly needed, how it should be generated, and how it can be verified. So this is why what we mean by an innovative approach. Many companies already collect a large amount of data, but this data often cannot be used for regulatory reporting or to make claims, to make it useful to their advantage, because it lacks structure, it lacks verification. So we have also included in the CERA 4-in-1 standards in the downstream, as well as in the chain of custody standard, the DPP attributes, that is the digital product passport attributes, and traceability requirements. The standard turns this existing data, which is there, into usable, decision-relevant information that can be put in the digital product passports. Another example is scalability. Instead of expecting every actor in the supply chain to adopt complex digital systems, the standard is allowing different levels of digital maturity while still ensuring consistency through defined requirements and verification mechanisms, through our technology and innovation theme. So rather than replacing the human judgment or governance, this approach combines digital tools and standards and also verification to address the very challenges that we discussed earlier. Finally, the CERA 4-in-1 standards also we include an LCA, that is life cycle assessment methodology. It is relevant to the battery industry in line with the EU battery regulation that has recently come out, so which the organizations can actually use as a guidance document, and they can generate comparable environmental impact information in line with the regulatory requirements. Next slide, please. So to conclude, this brings me to the way forward. The next step is not an immediate large-scale rollout, but to conduct more pilots. That is, pilots allow emerging traceability technologies to be tested in the real supply chain settings while using a framework like our standard that helps identify what is actually working and what is not actually working before scaling it up. For example, instead of asking companies to restructure their entire system based on theory, a pilot might actually focus on one material, one supplier, or one process. So we also conducted a pilot for the downstream for the CERA 4-in-1 performance standard and also the CERA 4-in-1 chain of custody standard to see where we can improve, how the organization that we actually had the pilot in, how they can leverage these standards and as well as improve the value in their operations, allowing learning and improvement for both of us. So second priority is transparency. So for traceability to be actually meaningful, information must not only just be there, it must be understandable, it must be comparable, and ultimately it must be trusted by the different stakeholders across the supply chain. But what must be reduced is the manual reconciliation of all this information. By defining the clear data requirements and processes, the reliance on manual data checks and ad hoc corrections can be significantly lowered, and it needs to be. And finally, addressing the aspect of fragmentation. Rather than adding yet another layer of requirements, the focus should be on harmonization, aligning the data, definitions, and processes, and the expectations through standardization and clear guidance for the organizations, for the auditors. For example, two suppliers out there. Both of them are saying that their material is coming from this particular source. So one is using the word source, and the other one is saying their material is coming from this origin. So without any clear definition, this information cannot be compared meaningfully. So by standardizing what source and origin means, for instance, in the context of traceability, we can convert this information that can be trusted and compared, and we can reduce fragmentation. So overall, the goal is not to collect more data or to integrate a more sophisticated technology, but better alignment between the systems, between the standards, and their application in real-world supply chain practices. Thank you. Over to you, Lucas.
Yeah, thank you very much. And we are good in time. So thank you very much for the speakers. Yes, we will share the presentation afterwards. We will do some addings on the presentation to put some slides more in, just that you have more information. And are there any questions so far? Not in the chat, but maybe you have questions now. I don't see so far. If your microphone is muted and you're not able to activate it, you can also write it down in the chat. Everybody was very clear. A challenging topic, very clear. And therefore, I would like to thank you very much for your participation. And please, as Daniel said, stay tuned of the MaDiTraCe project. And therefore, we can end up the recording and wish you a successful day ahead. Thank you very much.
Thank you very much.
Thank you very much. Goodbye.